So I need to find the derivative of this function. And whenever I have a function that has a radical sign, I like to change it to a fractional exponent. Because when I take derivatives and I use the power rule, that's just going to make it a whole lot easier. So it's x divided by 1 plus x squared to the 1/2 power. So I have a quotient here. So my quotient rule is uv minus uv over v squared, and my derivative kind of moves from front to back. So taking this just a little step at a time, I have y prime is equal to, well, u prime would be 1, because the derivative of x is 1, times 1 plus x squared to the 1/2, minus u, which is x, I'll put a bracket there, times, now I have to do the derivative of v. So I'm going to do outside in. I'm going to start with the outside, so the derivative of v is 1/2 1 plus x squared to the minus 1/2. That's just taking it as if I'm leaving my inside alone, times the derivative of the inside. Well, the derivative of 1 is 0. The derivative of the x squared is 2x. All of that is over 1 plus x squared to the 1/2 squared. If you're uncertain, you might, especially about this part here where I use the chain rule, kind of just go back and think about how am I going to do the derivative of that piece right there. So now it's time to use some algebra to see if we can simplify this a little bit. I'm pretty sure that we can. So y prime is equal to, well, there's not much I can do to simplify that, so I'm going to leave that at 1 plus x squared to the 1/2. I guess I simplified it by getting rid of the 1 there. Minus, well, x times x is x squared, and 2 times 1/2 is going to be 1. So those two things are going to cancel each other out, but I'm going to have in the front of this, I'm going to put x squared, and that's going to be multiplied by 1 plus x squared to the minus 1/2. So I just did a little bit of algebra there, not much. And that's still divided by 1 plus x squared. Well, actually, 1/2 to the x squared to the 1/2 squared, those cancel out. So it's divided by 1 plus x squared. So in my numerator, I have a binomial. I have a binomial because I have one term here and another term there, and they're just connected there by this minus sign. And I can see that I have a common term in there. It's a little bit hard to see, but I'm going to try and factor out a 1 plus x squared to the negative 1/2. So I'm going to go y prime is equal to 1 plus x squared to the negative 1/2 times, well, I'm going to take a little tangent here just to show you what I'm going to do right now. So if I had x to the 1/2 minus x to the negative 1/2, and I factored out an x to the negative 1/2, well, I know that this minus over here would be a 1, because when I distribute this to that, it's going to be x to the minus 1/2. But this is just going to be x, because x to the minus 1/2 times x is x to the minus 1/2 minus 1, plus 1, adding the exponents, and that gives me x to the 1/2. So taking what I did over here and putting it into this problem here, I factored out this, which was to the minus 1/2, and I have this same base here to the plus 1/2. So this part of the binomial is just going to be 1 plus x squared, that's to the first power, minus just the x squared right there. Because, again, I factored this out, it becomes a 1. So I'm going to close my parentheses, and I'm going to put this all over 1 plus x squared. So as you can see, this is getting into some pretty nasty algebra. That's not that nasty, but it's getting into some algebra that might be a little bit uncomfortable. So if you're not sure as to what I just did, I want you to stop the video, write it down on a piece of paper, and kind of go back and see if you can figure out how I got to that. Now, part of the reason I got to that is because now within this parentheses here, I have a plus x squared minus an x squared. So those are going to cancel out. And I'm going to have y prime is equal to 1 plus x squared to the minus 1/2 times 1, because those canceled out, divided by 1 plus x squared. Well, this is getting kind of interesting. So what I'm going to do now, since I have the same base, I'm just going to make this y prime is equal to, well, I can do one thing, I can go 1 over 1 plus x squared to the 3/2. Again, moving this exponent here down to the bottom. Or I could say it's the same thing as 1 plus x squared to the negative 3/2. And that's my answer. I'd like to check my answer on the calculator, so I put in my original equation into the y equals. And you can see I made it to the caret 0.5, which is the same thing as to the caret 1/2. Same thing as the square root of 1 plus x squared. And now I want to put in the graph of the derivative of this function. So alpha f2, 3 for n derivative, and I want to make it of my y1, so alpha f4 y1. I want the derivative with respect to x, and instead of an actual value, I want all my x values. So I put a parentheses there. And now if I go zoom 6, I get the graph of my function first, that's my y1. And then I'm going to get the graph of my derivative. It's a little tiny thing there. So I can see I kind of need to change my window here. I need to get expand my y's there. So I'm just going to go to my window, and I'm going to change my y minimum to like -3 and my y maximum to +3. And I'm going to push graph, and let's see what it looks like. There's the function. And here comes my derivative. My derivative, I can see, is going to be 0 for much of that way because my slope of my original function is flat, it's horizontal, or very close to it. There's my derivative. Now I'm going to go to my y equals, and I'm going to enter in the equation that I got for my derivative, which is parentheses 1 plus x squared, close parentheses, caret, parentheses, -3 divided by 2. I could have gone -1.5, but I did it the way that I had it written. And I'm going to make it so that my original function doesn't graph. And now I'm going to go graph. And it's going to graph first my derivative that I did by using the NDer function, n derivative function. And now it's going to graph my derivative as the function that I did it, that I calculated, and I'm not seeing anything different. It looks like they're overlapping. So I'm pretty comfortable now that I'll have the right answer here, that this, in fact, is the correct answer.